when you have something like this, something where, or a situation where there's a number attached to the theta, either through multiply, divide, add, subtract, whatever, there's a step that you need to do extra. The process is still the same, but there's a little, extra few things that you need to do. The first extra thing you need to do is adjust your interval. Your interval in this case is for theta. You don't have theta though. You have 3 theta. So your range is now adjusted to 0 times 3, 0, and 360 times 3, 1080. Okay, now you're going to solve as per usual. However, you're going to solve for 3 theta. Cos minus 1 of 0.766, which gives you 40.0 blah blah blah. You have now solved for 3 theta. At this point, if you want theta, you would divide 40.0 by 3, which is what you're going to do, but at the end. First, you want to find all the equivalent angles between the interval 0 and 1080. So we do our cast diagram. We draw 40 degrees. It's cos, meaning, let me move that back down. It's cos, meaning it's going to reflect there. So this is also 40 degrees. So your first solution is 40. Your second solution is 360 minus 40. So 40.0. Yeah, same thing. So 40 and then 320. But remember, your range goes up to 1080. So you can go all the way around until you hit another arrow. So this is going to be 360 plus 40, 400. Can you continue that until you reach your limit? So the next one would be 680. You would get by going all the way around and then hitting that one. 680 degrees. Then 760. Then 1040. If you try and go around another time, you're going to be over your maximum, your 1080. Okay, now that you've got all your values, now you can divide them all by 3. 40 divided by 3, 13.3 degrees. 320 divided by 3, 107. Then 133. Then 227. 253. 347. And now those values fall within the range of 0 to 360, which is what theta was originally confined to. But that's how that works. So first you want to adjust your range, then you want to solve, then you want to find all the values, and then you can divide or multiply or add or subtract, whatever you need to get theta on its own. Okay, let's try another one. This one. Step 1, change the interval. We don't have x on its own, we have x plus 60. So x plus 60, 60 degrees, 0 plus 60, 360 plus 60, 420 degrees. You're solving for x plus 60. X plus 60 is equal to sine minus 1 of 0.3, which gives you 162.5, I think. Let me check that. Sorry. 17.457 blah blah blah. So let's go 17.5 degrees. Okay. Let's draw cast diagram. CAST 17.5 is there. We have sine, meaning it reflects that way, 17.5 degrees. Our first arrow would technically go there. However, our range is from, or starting from 60. So instead, we're going to do this. 180 minus 17.5, which is 162.5. So theta x plus 60, sorry, there we go. X plus 60 is equal to 162.5. And if we go another, like this, 360 plus 17.5, 377.5. Okay. Can we go any further? No. If we try and go for, let me get rid of this. If we, if we try and do that, we're outside of the 420 range. So our only two values are 162.5 and 377.5. Now you apply your inverse. Now you minus 60 from both of them. So 102.5 and 317.5. Those are your two answers. Okay. Can you try those two for me, please? So for the first one, adjust your interval. 20, x plus 20, 200. X plus 20 is sine minus 1 over half, which is 30, I believe. Cast diagram, 30, 30. First value is 30. Second value is 150. Can we go any more? Nope. So your values of x are 10 and 130 degrees because you minus 20 from both. Cool. Part B. 0, 2x, 360. Cos minus 1 of minus 0.8 equals 2x. It says give your answer to one decimal place. Cos minus 0.8, 143.1. Cool. Draw cast diagram. 143 is something like this. It's cos, so it's going to reflect there. That's also 143.1. We've got 0 to 360 to work with. solution number 1, solution number 2. 360 minus 143.1. So 216.9 degrees. So x is 143.1 divided by 2. 71.55, so 71.6 because 1 decimal place. 216.9 divided by 2. 108.45, so 108.5 to 1 decimal place. There you go. Those are your answers. And that is how you apply adjustments when solving trig equations.